Hello everybody, my name is Sergey Nosov, and this video is a short introduction to unit testing with C#. We're going to be using Visual Studio 2019, and let me make a couple of notes about the environment. We're using here Cascadia code font with ligatures, and I have ReSharper installed with the Visual Studio keyboard shortcuts scheme. Great, so let's begin by creating a new library project. New project, type library, and we're going to create a .NET standard library with C#. Right, let's call our library fancy library. Right, great. Okay, we can delete this class, and our library is going to have a class that we're going to call rate calculator. And let's make this class public. And this class is naturally going to have a very useful method returning a string, and the method name is phasebuzz, and it's going to take an integer parameter. So we're going to need to implement the method. For now, it's just going to throw a not implemented exception. Throw a new not implemented exception. Great. So in any kind of software, we normally want to program against interfaces. So the rate calculator could be one implementation of a rate calculator interface. So let's pull this to an interface. Okay, extract interface. Right. Very good. So we have the iRate calculator interface. We're probably not going to use it in this video, but this is a normal state of affairs in programming, where you normally want to program against an interface rather than a concrete implementation. So, very good. Now, let's create our unit test project. Okay, add new project, and Visual Studio out of the box gives us a choice of MS test, and unit, and X unit. And unit and X unit are probably the most popular unit testing frameworks. There are others. There is no clear winner which one is the best. We're going to use X unit in this video. Right, and the name of the unit test project is going to be starting with the same name as our fancy library, and then dot tests. Very good. Okay, let's delete this automatically created unit test and add new item. We're going to create a class to test our rate calculator. So we're going to call that class rate calculator tests. Calling it like this is actually pretty convenient. It gives you an ability to go from the class to the unit tests. Yeah. You can start typing rate calculator, and you can see, or you can switch quickly between your class and your unit tests. That's very convenient. Now, unit tests normally are public, so we can make this class public. And let's start by writing our first unit test. To tell the system that it is a unit test, we normally use attributes. And for XUnit, the two attributes are going to be using the most are probably fact and theory. We'll start with the fact. Right. So we're going to need to give our first unit test a name. One of a unit test naming convention is given, when, then. It is a style that comes from behavior-driven development, or BDD. So we're going to define what actually happens. We're going to codify the requirements for the method that we are going to be testing. So let's give our unit test a name. Unit test procedures usually don't return anything, so it's a public void. And the method that we're going to be testing is this fizzbuzz method. It will take an integer and produce a string. If an integer is divisible by 3, the string it produces is fizz. If the integer is divisible by 5, the string it produces is buzz. If it's divisible by both 3 and 5, the string is fizzbuzz. Otherwise, it's just going to return the string representation of the integer. Easy enough. So let's start with the first requirement. If the integer is divisible by 3, then the result should be fizz. Okay. So using the given, when, then style of naming, we can name our unit test method given 3, when fizz buzz, then fizz. Now, the largest disadvantage of this style of naming is that these names could get verbose sometimes. But the main idea here is that just by reading the name of the test, you should be able to figure out what is going on even before you start reading the implementation. Sometimes it's easier said than done, but you should definitely try to make your unit test names as descriptive as possible. Very good. So now inside the unit test, the pattern that we normally use is referred to as AAA. It's arrange, act, and assert. In the arrange part, we create the environment for the unit test to run. So in this case, we need to create our calculator. And since we are testing just one value here, 3, we create a constant for it. Now, that's it for the arrange part. Act is where we actually execute whatever we are testing. So we're going to grab some output from the calculator fizzbuzz method. And the final assert part is where we make an assertion, where we test our results of the act part to make sure that results are what we expect. We can do it like this. Assert equal the expected value and what we got in our act part. So we are comparing the output that we got here with something that we're expecting. Well, we're not expecting fuzz, we're expecting fizz. Yeah. So that looks like a complete unit test. Although, let me introduce you to a library that I like to use for making assertions. It's a Fluent Assertions library that we can add to our project. With this library installed, we can make our assertion more readable. Just take our output parameter and write it like this. output should be phase. Yeah, these two lines are equivalent. So the first one is how you do it without fluid assertion, and the second one here is using the fluid assertions library. I think the second line is easier to read, so I'm just going to keep the second line. Now we have our complete unit test. Let's try to run it and see what happens. Our project is building. Our unit test runs, and as expected, it's red. Unit test failed. Well, naturally, because we haven't implemented anything yet. This type of development sometimes referred to as red-green development. We start by writing a unit test, we run the unit test, and we get the red result. Unit test fails. That's how we know that our unit testing infrastructure is operational. So now, when the unit test is done, we can go and implement our actual FizzBuzz here. So our unit test expects us to have a string with value fizz, so let's give it a string with value fizz. Let's run the unit test again and see what happens. Oh yeah, capital letter. The unit test expects the capital F, and we gave it small f, so let's fix that. See what happens. Hey, our unit test passed. Very good. It's not a very useful test because it just checks one value, just checks 3. And remember, our requirements were that anything divisible by 3 should return fizz, anything divisible by 5 should return buzz, and anything divisible by 3 and 5 should return FizzBuzz, etc. So we need a fancier unit test for that. Let's write that unit test. And we are going to use a theory attribute for that. Let's name our unit test given an integer when is pause, then produce string. We're going to take an integer input parameter, and we're going to produce some string, and we're going to expect the string to be fizz, FizzBuzz, buzz, or just a string representation of an integer if it doesn't fall into either of those. So we'll call this parameter expected. And with the theory, we can give our unit test input values and expected parameters. So let's start writing those. We use inline data attribute for that. So if we give fizzbuzz 1, it should return 1. Now, if we give it 2, 2 is not divisible by 3, not divisible by 5, so it returns 2. Now, if we give it 3, it should return fizz. This is similar to this test. So this fact is also part of this theory. Input parameter 3 and the expected value of fizz. Right. Let's continue. When the input is divisible by 5, we get buzz. If it's divisible by both 5 and 3, we should get fizz buzz. And let's add more tests with some larger values here. Now, what if we get 199? This is a prime number, so it's only divisible by itself and by 1. So it's not going to be divisible by either 3 or 5. So it will return 199. Let's get some larger numbers that are divisible by 3. So if we multiply 3 by a couple of primes, 193 is a prime, and 197 is also a prime. So this should work. This should still return fizz. And let's do similar for buzz. Let's make it even bigger. Multiply by 193, 197, and 199. And also, let's get a larger fizzbuzz value. Multiplied by 1024 a couple of times, and let's not forget about a negative number, so minus. Right. This is our theory, and this are the values that we're going to test against. Now let's write our unit test. Again, we start with the range part. Then we act. And here, instead of passing a constant parameter, we pass our input parameter of the unit test procedure. And of course, on the fizzbuzz method of class that we are testing. And now we do the same thing. We assert output should be expected. Very good. Let's try to run our unit tests. Now, in the unit test explorer, we can see that each of the inline data theories run, and the only successful ones are where we expect the parameter phase, which makes sense. Our function here always returns phase, so everything where we expect anything but phase fails. So let's go now fix that. And FizzBuzz is a known exercise. They are actually contests who can implement it the cleanest, the fastest, with the least amount of code. We're not going to win any contests here, though the project for this screencast is available on GitHub at github.com/orderfactory/unit-testing-intro. So feel free to clone this project and submit a pull request with your implementation of FizzBuzz. Maybe you can make, I'm sure you can make a more beautiful, faster, smaller one. But for now, let's do something simple. So going to need a private method that will tell us if a number is divisible by another number. Let's call it divisible by, and it's going to have two parameters, the number and the divisor. And we are going to get the remainder of the division. And compare it to 0. If it's 0, then the number is divisible by the divisor. So, all right, very good. Let's check first if our number is divisible by 3. Divisible by 3. Also, let's check if it's divisible by 5. Great. Now, so if it's divisible by 3 and divisible by 5, we're going to return FizzBuzz if divisible by 3, going to return phys, right? What else? If it's divisible by 5, right? We're going to return buzz. Otherwise, we're going to return the string representation of the number. Okay. Let's see if that works. Let's run our unit tests. Bam! It works. All unit tests pass, and you know what that means? That means we are done. Let's make a commit. Implement fizzbuzz. Right. One thing you might notice here that everything is synchronous. And these days our code is normally asynchronous. Let me show you really quick how to write asynchronous tests. With synchronous tests, our test methods are methods return void. With asynchronous test, we want to return task. So let's do that. And they also become asynchronous normally. Right. So async code tends to propagate. Our call to fizzbuzz is going to be a synchronous call, so we're going to await it. And let's do it in both tests. So instead of void, it's async task. And we're waiting on our fizzbuzz method. Okay. Let's go to implementation and actually change the code to async. So instead of returning a string, I'm going to return a task of string. Right. Right. And instead of boolean, we're going to return a task of boolean. Let us pretend that calculating the remainder is an expensive calculation. So let's say it takes 5 seconds. Right. Just kind of makes sense. Because division is usually more expensive than addition or multiplication. Right. Okay. So instead of divisible by 3, this becomes divisible by 3. Task, and divisible by 5. Task, which we need to wait on. Divisible by 5. Right. Now let's start running our unit tests. Let's start with the first one that we wrote, the one that checks that if the number is 3, then we should get fizz. Before we do that, let's show execution time of the test. Right. The test is running and it's a success. Where is our execution time? Oh, here it is. It took 5 seconds to execute the test, which makes sense. See, factoring is an embarrassingly parallelizable operation. We don't have to wait to see if the number is divisible by 5. We don't have to wait for if the number is divisible by 3 operation has finished. So we can do both. Check the division by 3 and by 5 at the same time. This is where it happens. We are creating a divisible by 3 task and creating divisible by 5 task. These tasks run simultaneously, and then we await on both of these tasks asynchronously. So that's why the entire test executed in 5 seconds and not in 10 seconds. Right, let's reduce the delay to 5 milliseconds and run all of our unit tests. Right. Success. Everything runs, and you know what that means? That means we are done. Thank you for watching. If you want to grab the repo, again, it's available on GitHub at github.com/orderfactory/unit-testing-intro. Thank you for watching, and I hope this was a good introduction to unit tests for you. Bye.